guys, welcome to day 16 of the 28 days data science AI Gen AI challenge. So today I'm going to talk about a CNN code on which we are going to work on a data set called CIFAR10. So 10 represents the 10 labels what we have. But to understand this, right, try to understand the concept of how does a camera detects the objects. So if you would have seen some videos where it would be able to detect the person, the dog, the car, the vehicle, so something like that. So we have a data set which, based on that, we are going to do a CNN model upon it, and we'll see how it happens. Okay, so very quickly, the introduction about the data set. So it is a CIFAR data set. It consists of 5,000 training data set, 10,000 testing data set. The challenges are it can be, because of low resolution, right, that can be a problem where distinguishing between bird and a plane. But we'll try to understand how does this happens. So technically it has different kind of labels like aeroplane, automobile, bird, cat, deer. It goes on like that. If you want to increase the speed of the video, you can increase by 1.5x. So I've explained the CNN architecture in my past videos also. I'll put in the description for your references. But if I want to do a very quick understanding what the CNN architecture has, before we go for a neural network, I do some level of data operations on image data set. For example, convolutional layer and pooling layer, which I've explained in the videos too. This is a quick diagram about what happens behind the box. So before we go to the neural network, we do set of operations on the images called convolution and the pooling, which technically extracts the important features of the image and tries to give it the fully connected layers later. So when you're training, remember to use the library called TensorFlow, the epoch, how many times it is going to do the optimization stuff. The batch says how much file it is going to use, the learning rate of with the help of Adam. So I have explained the concept of epoch, the concept of Adam in my past videos of ANN, so I can put that into the description too. So as a resultant, what I have got is I've got the accuracy score of somewhere around 70%, between 7 to 75%. So I will say that this is a good fit model because the threshold is somewhere around plus and minus 5%. So if you see, the loss is also decreasing as we go on. So somewhere the model what I've created in the code, which I'm going to show you later, is a good model. So how you can use this? So take this data, try to go ahead with one more use case of CIFAR 100. It's much more difficult, but it would be interesting challenge for you. So if you have any question till here, please put forward this question in the comment box, and I will happy to answer those questions. I'll see you in the code side. In the previous part of the video. So today is day 16, and I've explained a CNN code with the help of a data set called CIFAR 10. Okay, so as you know, I have divided the code into different cells, different ideas. So I have put forward in title what exactly I'm trying to do. In my first line, I have put forward the links to my Discord server, the YouTube link, the LinkedIn. So there are multiple spaces where you can come and ask questions. Before you run this, always remember to change the runtime. Click on runtime, go to change runtime, and click T4 GPU, because when you're working with image data, it's very important you shift to GPU. Okay, if you want to know why, you can put your question in the comment box. I'm happy to answer. So I've brought the libraries, I've run the libraries, I've imported the libraries, I've extracted the data. What I have done, like my previous code, I have tried to see my first data set. Okay, so it is 32 by 32 with 3. So technically, when I say 3 dimension, so it technically has all the 3 dimension of red, blue and green. So I have tried to show you that too later below. So yes, so I have taken the first image, so this image, and the label is 6. So the label, it has label to frog. Okay, so there are 10 labels: aeroplane, automobile, bird, as you can see. So for the labeler who has done it, it has labeled as a frog. Let's see how good is the model after this. Okay, so what I have done, I've built the model, I've built the CNN. So if you see, it's very important with the fully connected layer, you have to have a convolutional base because it's an image. So I've taken the input size, my input layer. Then this is all my convolution layer, where I've done the convolution, then max pooling, the convolution and max pooling. Okay, if you want, if you're not getting a good model, you can increase the convolution layer and check again. Okay, so I have done that. I've compiled the model. I've taken Adam as my optimizer, accuracy as my matrix. Then I've done 10 epochs. If you see, this is the 10 epochs which has run. Then put forward the the scores for you so that you can share it to your stakeholders. If you see here, I can clearly see that the validation score and the training score are somewhere around 7 to 75%, which is very good within the threshold of say plus and minus 5%. My losses are also reducing as the epochs is increasing, so it's very good. Okay, so if you have any question till here, please put forward a question in the comment box. I'm happy to answer those questions, and please do subscribe. I can see a lot of people are viewing the videos but not subscribing, plus because it does help me to, it does inspires me to create more videos. Thank you guys. If you have reached till here, it means that you have finished the video. Thanks for watching and being part of the 28 Data Science Challenge. Your support, engagement and enthusiasm make this journey even more exciting for me. If you found this valuable, drop a comment, share your insight and tag a friend who should join us. Let's keep learning, building and growing together in the AI engine AI space. Make sure to like, subscribe and stay tuned for the next challenging stuff what is going to come tomorrow, because we have just started and it's going to get better and better as we go. Bye.